Hi, welcome to the 2-6 day 2 notes on angle proofs. Couple review things first before we start the 3 proofs. One is the definition of angle bisector says that if ray BD, and it doesn't really look like a ray right here, it looks like a line segment, so I'm going to try and make a little arrow on that. If ray BD bisects, remember that means or cuts in half angle ABC, then what? And reference to this particular picture, we can see that angle 1 must be congruent to angle 2. So I can say that angle 1 is congruent to angle 2. Angle addition postulate says that the two little angles have to add up to the big angle. So in this specific case, the measure of angle 1 plus the measure of angle 2, those two little angles must add up to the whole big angle, which is the measure of angle ABC. And the last one is definition of a straight angle. In this case, this is not in reference to the picture above. It says if angle Z is a straight angle, then what would we know for sure about angle Z? And that's that measure of angle Z has to equal 180. Okay, so let's go and try some proofs involving this information. So on example 1, what's given is that angle ABD is congruent to angle EBC. Anything that's given to you, specifically given to you, you can go ahead and mark on the picture. So if I look at angle ABD, I can see that is in reference to here, and that is congruent to EBC, which is in reference to here. And what I'm trying to prove is that angle 1, this angle, is congruent to angle 3, this angle. If I'm trying to prove it, I don't want to mark it congruent yet, but sometimes I'll star it or at least look at it so I kind of have in mind what I'm trying to get to by the end. So we know that the given information has to be first, so angle ABD is congruent to angle EBC, and that is given. Okay, from there, I know that if I am going to work with angles and things like that, if I'm working with any type of an equation, I have to have an equal sign. I can't do that with the congruent sign. So if I want to switch from the congruent sign to the equal sign, I can say measure of angle ABD is equal to the measure of angle EBC, and that is the definition of congruent angles. Some people just call it definition of congruence, and that's fine if you want to do that. I usually say definition of congruent angles if I'm working with angles, or definition of congruent segments if I'm working with segments. So that's up to you. All right, next thing, now that I have equal sign, I can bring an equation into the problem. So if I look at this picture and try and think what is a true equation I can say about this information in the picture, that is that we're talking about two different angles, and I see two little angles that make up the bigger angle. So I can say the measure of angle ABD is equal to the measure of angle 1 plus the measure of angle 2. I can also see that the measure of angle EBC, and I'm putting all this at one line, measure of angle EBC is equal to measure of angle 2 plus measure of angle 3. Okay, so I put all of that in line 3. There's not a lot of room, but I tried to squeeze it there. And that's supposed to be a B. And that is the angle addition postulate, like we just reviewed up above. Where, again, the two little angles have to be equal to the big angle. All right, from there, again, keep looking at what you're trying to prove. I'm trying to prove that 1 and 3 are congruent to each other. Right now, I can see 1 and 3. I have 1 and 3 in an equation, but they're in different equations, and somehow I need them into the same equation. So in that case, if I know that angle ABD is equal to all this stuff, I can put it in for ABD's place. And if I know that this stuff down here is equal to EBC, I can put all that stuff into EBC's place. Okay, and try and think of what is it called when you're putting something into something else's place, and hopefully you're thinking of substitution. So if I do that now, instead of ABD, I can say measure of angle 1 plus measure of angle 2. Remember, that's like the substitute teacher coming in place of the teacher. And then I can take the angle 2 plus angle 3 and stick it in for a EBC. All right, and again, I put something into something else's place, so substitution. Okay, and now again, we're trying to end up with 1 and 3. Keep that in mind. I see the 1 and 3, it's in the same equation, but there's too much stuff in the equation. I need to get rid of some of it. And so hopefully you're thinking that we can subtract measure of angle 2 away from both sides. Remember, you're allowed to do anything you want to an equation as long as you do the same thing to both sides. So if we subtract measure of angle 2 away, we're left with measure of angle 1 equals measure of angle 3, and that is subtraction. And then from there, we're just changing from the equal sign to the congruent sign. And that is definition of congruent angles again. All right, moving right along. On example 2, again, it's hard to see these little ray symbols. So I'm going to say ray AC and ray AD. So ray AC bisects angle BAD. So if ray AC cuts angle BAD in half, then I know this angle is congruent to that angle. And if ray AD bisects angle CAE and cuts it in half, then I know that this angle is congruent to this angle. And what I'm trying to prove is that angle BAC, this angle is congruent to DAE, this angle. So again, first I need to get my given information into my proof. So I've got ray AC bisects angle BAD. And I'm also going to go and stick in there that ray AD, that's not looking very good. Let me try that again. Okay, so I've got ray AD bisects angle CAE. Okay, and all that's given. All right, from there, I know that, okay, actually, I went ahead and marked them congruent in my picture at the beginning, and I probably should not have done that yet. And the given is telling me they bisect, but they're not specifically saying they're congruent. So because they bisect, I know they're congruent, but I need to actually say that in my proof. So I should have waited till line 2 to mark them congruent. So I'll go ahead and do this part now. So now I can say angle BAC is congruent to angle CAD. And put it beside angle CAD is congruent to angle DAE. So basically it's just the things that I marked congruent at the very beginning. Okay, the reason that I was allowed to mark those is because of definition of angle bisector. Okay, because I knew what that word bisect meant in the given. That's how I know that those two angles must be congruent to each other. Okay, from there, see how if BAC is congruent to angle CAD and angle CAD is congruent to angle DAE, then what must be congruent is that these two must be congruent to each other. And hopefully you're recognizing that transitive property. Again, transitive property works when there's an equal sign or a congruent sign. So I can go ahead and say that angle BAC is congruent to angle DAE by transitive. So that was a nice short proof. Again, you're keeping in mind the whole time what you're trying to prove and we were just able to get there much more quickly this time. All right, one more proof, then you're done with the chapter 2 notes. I'm trying to decide if I'll have room here. I'm going to make it a little bit smaller so you can see it. Okay, so on example 3, what's given is that angle HGI, which is this angle, is congruent to JKM. I want to actually mark them congruent. Okay, so HGI is congruent to JKM. So those two angles are congruent. What we're trying to prove is that HGF is congruent to MKL. Okay, and at quick glance, it should make sense to you that those are congruent. Okay, if you just kind of think through the proof, oh yeah, I see that, the first set of angles is forming a straight line, so they have to add up to 180. I can see the other set of lines is forming a straight line, so they have to add up to 180. And if the two little angles are congruent, the two big angles must be congruent. So sometimes you can kind of make sense of a proof just by looking at it, but then you've got to do the work to get all the information down on paper in a logical way and using the correct reasons. So let's go ahead and start with the given. We know that angle HGI is congruent to angle JKM. And we know that first reason is given. Okay, then for line 2, we have to think, what do we know from that? Well, I have a feeling that I'm going to need an equal sign. I'm going to need some true equations. So I need to switch that congruent symbol to an equal sign. So I can say the measure of angle HGI is congruent to the measure of angle JKM. And again, like we used in the last one, that's definition of congruent angles. Again, anytime you're switching from a congruent sign to an equal sign or an equal sign back to a congruent sign, and I accidentally didn't put equals here, I put a congruent again. So fix that, and that's supposed to have an equal sign, and I did put the little m's in front like I was supposed to. All right, on number 3, again, similar to the first proof we did today, where if I want to refer to the angles in the top picture, I can say the two little angles add up to the big angle. So in this case, I can say measure of angle FGI is equal to the measure of angle HGF plus the measure of angle HGI. And I can also say that for the bottom picture, I can say that the measure of angle JKL is equal to the measure of angle JKM plus the measure of angle MKL. And that is using the angle addition postulate. Okay, where again, the two little angles have to add up to the big angle, and also make sure you're naming the angles with, if you're naming with 3 letters, that the middle letter is the vertex. All right, from there, you can see that in terms of what I am trying to get to, I can always substitute something that's equal to something else, in. So in this particular case, I'm going to take this measure of angle HGI, and since it's equal to measure of angle JKM, I am going to stick it right here in for JKM's place. If they mean the same thing, I'm allowed to do that. So, and that will help me get to where I'm trying to go. So on line 4, I'm going to say measure of angle JKL. I'm not worried about the first equation at the moment. Measure of angle JKL is equal to, I'm going to say measure of angle HGI this time, plus measure of angle MKL. Okay, and I put something into something else's place. So that is substitution. Okay, from there, it's not necessarily following in line from something I've already done, but again, I can always look at the picture and bring something new in from the picture. In this case, I can see that both of those angles are straight angles in the picture. And that was one of the definitions we reviewed over at the very beginning. So I can say measure of angle FGI is equal to 180. I know that has to be true. And I know that measure of angle JKL has to be equal to 180. And my reason for that is definition of straight angle. Okay. I'm getting closer to being done. This is a longer one. On number 6, line 6, here's what we're going to do now is that I know that if these two angles are both equal to 180, then I know for sure that those two angles must be equal to each other. So I can see that the measure of angle FGI let's see. I can put it right there. Okay, it doesn't really matter which side I put it on. But again, if I know that FGI is equal to 180 and I know that JKL is equal to 180, then I know those two angles must be equal to each other. So I can say that the measure of angle FGI has to be equal to the measure of angle JKL. And again, that is substitution. Okay. From there, we're getting so close. Okay, from there, I know that I can substitute again. If I know these two things are equal, and if I look back up a bit, I can see that FGI, another thing we had called that, was right here. So I'm going to bring that around to here. And then for JKL, we had said a few minutes ago that in line 4 that 8's equal to HGI and MKL. So I can come and substitute that in right here. So now my next line says that the measure of angle HGF plus the measure of angle HGI is equal to measure of angle HGI plus the measure of angle MKL. And line 7 here is once again substitution, lots of substitution. And from there, again, keep in mind what you're trying to get to. You're trying to get to the fact that HGF is congruent to MKL. And at this point, I can see the HGF, I can see the MKL, but there's too much stuff in my equation. I want to get rid of some of it. So just like we saw before, I need to subtract it away. So measure of angle HGF is now equal to the measure of angle MKL. And I could subtract away this HGI from both sides. Okay, so I got my subtraction property. That is what I'm trying to prove, except there's an equal sign and I want a congruent sign. So last step, I just need to switch those. And I've got HGF, angle HGF is congruent to angle MKL. And again, that's definition of congruent angles, because I switch from the equal sign back to the congruent sign. Okay, so that's it for the section 2.6 day 2 notes. We'll practice over some of these things with the review sheet before the test. But please let me know if you have any questions. Have a good day.